China now produces nearly half of the world's cars and leads global electric vehicle sales by a wide margin, reshaping an industry that once anchored the American middle class. Picture humming Rust Belt assembly lines shrinking as sprawling Chinese megafactories run 3 shifts, churning out low-cost EVs and components that flood global markets. Over the past decade, policy choices, mass subsidies, targeted supply chain investments, and aggressive export strategies met with corporate misreads and deferred innovation in the U.S., producing a measurable shift in market share, trade flows, and jobs. This video walks you through the official numbers from the China Association of Automobile Manufacturers, the U.S. Department of Commerce, and other agencies to show how production volumes, EV adoption rates, and trade balances flip the balance of power. Watch to understand the pivotal years, the turning points, and the concrete figures that explain why the auto empires are colliding, and what that collision means for economies, workers, and consumers worldwide. The European surrender. Official reports from the European Commission, ACEA, and the International Energy Agency laid out the structural shift that underpinned the story. Europe's vehicle industry was no longer insulated from global shifts in battery cell manufacturing and component supply chains. The IEA's assessments showed Asia's concentration of cell production and upstream refining capacity, and ACEA's production and registration summaries highlighted widening gaps in competitiveness for traditional European OEMs. Consequently, Brussels moved from exhortation to regulation, invoking new screening tools and trade probes to address perceived distortions in the internal market. The market reaction was immediate and visceral. Chinese EV makers moved into multiple European segments with cost-competitive models and integrated battery supply strategies, and national registration datasets in several markets recorded rapid share gains for those newcomers. European consumers responded to lower prices and long electric range. Short-term sales wins translated into long-term strategic pressure on assembly lines and Tier 1 suppliers, many of whom faced retooling costs and squeeze margins that they could not easily absorb. Industry-level decisions followed in a chain. Plants that had once churned internal combustion engines were retooled or idled, joint ventures were reconsidered, and procurement strategies shifted toward imported cells and modules. The European Battery Alliance and critical raw materials initiatives were intensified, while the Commission's foreign subsidies oversight and anti-subsidy investigations targeted the competitive practices behind the surge. Governments offered targeted state aid and restructuring support, but those interventions often came after market share had already migrated. The human costs surfaced in supplier towns and in company boardrooms. Workforces faced retraining requirements that the social safety nets and retraining programs struggled to match. At the same time, executives negotiated complex trade-offs: accept imported battery cells and preserve short-term production, or invest heavily in domestic gigafactories and absorb years of cost disadvantage. Some firms pursued both paths. Others consolidated or shifted platforms to focus on profitable niches, effectively conceding mass-market segments to better capitalized entrants. Strategic surrender was neither theatrical nor uniform. It took the form of policy concessions, procurement compromises, and painful corporate resets. European policymakers moved to shore up critical inputs and to clamp down on distortive subsidies. Yet industrial capacity decisions made in boardrooms, plant closures, platform rationalizations, and supplier realignments often sealed the outcome. The resulting landscape is fragmented. Resilient pockets of high-value engineering and niche markets remain, but the mass-market architecture of cars, batteries, and supply chains now stretches far beyond European factory gates. The takeover, legacy brands, Volvo, Lotus, MG, are already Chinese. Mercedes and BMW are next. Zhejiang Geely Holding Group is the parent company of Volvo Cars, and SAIC Motor Corporation controls the MG mark. Corporate filings and company press releases make those ownership lines clear. Geely also established control of Lotus through a strategic acquisition and has publicly outlined investment and engineering plans for the British mark. These are not rumors, but formal corporate moves recorded in annual reports and regulatory filings. Capital infusion came first, then engineering and market strategy. After the acquisitions, new investment flowed into model development, electrification programs, and global distribution networks. MG re-entered European showrooms with competitively priced electric crossovers, leveraging SAIC's volume manufacturing and supply chains. Volvo's technology roadmap accelerated under Geely's ownership, with greater resources allocated to electrified platforms and shared engineering between Volvo and sibling brands. Lotus received funding to evolve from a niche sports car maker into a broader performance brand with electric models and leveraged Geely's access to chassis and battery technology. The narrative that follows is pragmatic rather than conspiratorial. Legacy European identities have been preserved on the surface, while underneath brand stewardship, product roadmaps and component sourcing have come under new strategic direction. Company annual reports, investor presentations, and regulatory filings show restructuring of R&D expenditures, cross-brand platform consolidation, and supplier contracts increasingly denominated in favor of high-volume Chinese manufacturers. If the pattern of acquisitions, capital deployment, and supply chain centralization continues, the next phase for Mercedes and BMW could be a shift in where key decisions are made, driven by the market power of suppliers, the lure of scale, and investors seeking returns, rather than headline-grabbing takeovers. The shift: Europe is no longer a manufacturer. It's a showroom for Chinese tech hidden inside old luxury badges. China produces more passenger electric vehicles than any other country, and its battery makers lead global capacity, according to industry associations and company filings. European auto production has shrunk as a share of the global total. Data from international manufacturing bodies and the European Automobile Manufacturers Association indicate. Major Chinese automakers now sell directly into European markets, and state-affiliated industry groups report growing export volumes of finished vehicles and components. Meanwhile, the European Commission has publicly flagged strategic dependence on foreign battery cells, semiconductors, and critical raw materials. The visible effect in city showrooms is that a historic badge no longer guarantees European origin technology. Volvo and Polestar, under Chinese ownership, develop product roadmaps that integrate Chinese platforms and supply chains. MG and other brands are distributed in Europe but manufacture many models in China, importing complete vehicles rather than running full-scale manufacture on the continent. CATL, the world's largest battery cell supplier by production capacity, supplies cells used in vehicles sold by European nameplates. Short supply chains matter. Longer manufacturing chains do not. Automotive suppliers' balance sheets and procurement reports show where the value lies. Chassis and bodywork still move across factories, but battery modules, electric drive units, and increasingly the core software stacks are being designed and sourced in China. Companies such as Geely created ownership structures that put engineering and platform development under a Chinese corporate umbrella, while keeping European brands and design centers intact for marketing cachet. The result is mixed. European R&D centers continue to refine tuning, interior finish, and branding, but the central propulsion and energy systems increasingly trace back to Chinese factories and suppliers. Dealers and consumers notice the change in different ways. A premium emblem can mask a control unit built by a Chinese Tier 1, or a high-end interior can sit atop a battery pack manufactured in Asia and shipped as a module. Policy documents from Brussels and national governments describe this as a strategic challenge and have launched measures to foster on-continent battery cell projects and semiconductor resilience. Still, the commercial reality is that many legacy European badges now function almost like showrooms, curating design and customer experience while the manufacturing and tech backbone increasingly originates in China. Fortress America. When the U.S. applied 25% of tariffs on imported steel and 10% on aluminum under Section 232, the move immediately recalibrated automotive input costs and supplier strategies, according to Department of Commerce releases. The parallel Section 301 duties targeted roughly $250 billion of Chinese goods and layered additional levies of up to 25% on categories that included components used in vehicle assembly and electronics, creating a cost shock that suppliers and OEMs had to absorb or pass along. Those measures were followed by legislative incentives that shifted the playing field. Buy America clauses in the infrastructure law and the clean vehicle tax provisions in the Inflation Reduction Act required North American final assembly and imposed domestic content expectations, forcing multinational manufacturers to reevaluate sourcing and factory footprints. Official announcements from the Treasury and Commerce Departments framed these as industrial security and economic resilience policies rather than simple protectionism. Washington then widened the toolkit beyond tariffs and tax language. FIRRMA expanded CFIUS authority to screen foreign investment in critical technology and infrastructure, and the committee began scrutinizing acquisitions and greenfield investments tied to battery chemistry, power electronics, and connected vehicle telematics. The Department of Commerce added export controls and entity list restrictions that curtailed transfers of advanced semiconductors and related tooling, with formal notices explaining national security rationales. The practical effect: companies reliant on cross-border technology transfers faced licensing delays, and original equipment manufacturers accelerated plans to localize Tier 1 suppliers for batteries and semiconductors. The public record from CFIUS filings and commerce rulemakings shows a sustained, systemic push to shorten sensitive supply chains. Automakers reacted in concrete ways. Several announced or expanded North American battery plants and joint ventures, committing capital to onshore cell production and cathode precursor facilities. State economic development agencies matched federal incentives with tax abatements and workforce grants. Labor statistics and industry reports underscore that manufacturing employment concentration and supplier ecosystems were central to the policy goal: preserve jobs tied to high-value assembly and advanced components. Procurement managers rewrote sourcing contracts, adding clauses to ensure compliance with content verification rules and to avoid potential loss of tax credits for end customers. That procurement rewiring rippled through tens of thousands of supplier contracts and forced smaller-tier suppliers to seek new financing or consolidate. Markets reacted with volatility, but strategic winners emerged. Firms that had already diversified manufacturing footprint across North America were better positioned to claim incentives and avoid tariffs, while those heavily dependent on Chinese origin modules or raw materials faced both higher input costs and regulatory headwinds. Public filings with the Securities and Exchange Commission and statements from the Department of Energy highlighted targeted grants and loan guarantees aimed at domestic battery manufacturing and processing plants, part of a coordinated effort to rebuild upstream supply chains. The narrative that unfolded in regulatory dockets and corporate annual reports was clear. Fortress America was less about isolation and more about engineered resilience. Legal frameworks and financial levers deployed to ensure critical vehicle technologies and the jobs that produce them remained under U.S. oversight. The strategy: 100% of tariffs and software bans. The U.S. isn't competing. It's building a wall to save Ford and GM. U.S. trade and national security authorities already include a toolbox capable of imposing sweeping tariffs and software controls. The Office of the U.S. Trade Representative can deploy tariff measures under trade law. The Department of Commerce's Bureau of Industry and Security can place firms on the entity list and restrict exports of sensitive technology. Customs and Border Protection can increase inspections and detentions at ports, and CFIUS can block or unwind foreign investment on national security grounds. These are real, codified instruments rather than political metaphors. Examples are visible in Commerce Department actions that restricted certain Chinese telecom firms from acquiring U.S. chips and equipment, and in congressional and executive activity to limit foreign software on government devices. Such precedents show how a policy architecture could be repurposed to erect barriers against imported vehicles and vehicle software. A 100% tariff, as a policy construct, would function as a de facto ban on price-competitive imports by doubling or more the landed cost of vehicles entering the U.S. market. It would be implemented through tariff proclamations or emergency trade measures and defended, if challenged, with arguments about national security or unfair subsidies. At the same time, software bans could be enforced by adding foreign vehicle software suppliers to restricted lists, by conditioning type approval on source code audits, or by mandating that critical vehicle telematics, over-the-air update platforms, and domain controllers use only approved domestic software stacks. Those are available enforcement paths. The Export Administration Regulations, the Entity List, and procurement rules already provide mechanisms to exclude foreign technology from critical systems. Putting such measures together transforms trade policy into an industrial shield rather than a competition strategy. For incumbent automakers that built legacy production footprints, seeking predictable volumes from dealers and suppliers, a protective wall reduces immediate market pressure from low-priced imports and vertically integrated foreign EV makers that bundle hardware with proprietary cloud services. But the cost is borne downstream. Tariffs act as taxes on consumers and on the supply chains that integrate imported components. Software restrictions force manufacturers to redesign electronic architectures or to find vetted suppliers, which raises engineering costs, lengthens certification cycles, and can delay product introductions. Regulatory compliance, software provenance checks, and enforced localization create new expense lines for procurement and R&D teams. Wider economic and diplomatic consequences are unavoidable. Trade remedies at that scale invite challenge at multilateral fora and retaliatory measures that target U.S. exports or supply critical inputs. Domestic manufacturers shielded from competition may avoid the investments needed to compete globally in electrification, connected services, and autonomous driving architectures. Meanwhile, agencies tasked with enforcement would face a surge in customs actions, export control licensing, and investment reviews that strain staffing and create legal uncertainty for suppliers and investors. The choice to build a wall rather than to compete through targeted industrial policy, incentives for R&D, or trade adjustment programs is operable within existing law, but is neither cost-free nor administratively simple, and official tools make clear the trade-offs between protection, market access, and technological resilience. The risk: can the U.S. survive as an isolated island while the rest of the world goes Chinese? According to the International Energy Agency and other official assessments, China now occupies a commanding position across the electric vehicle battery chain and a large share of finished EV production. Battery cell manufacturing, precursor chemical processing, and cathode/anode material refining are concentrated there. Major battery firms, such as CATL and BYD, anchor sprawling supplier networks that feed not only domestic auto assembly, but also overseas plants. The U.S., by contrast, still hosts important final assembly and design assets, but relies heavily on foreign sources for the most advanced and cost-effective cells and many raw material processing steps. That imbalance matters for survival if the global market shifts to Chinese-dominated standards, platforms, and suppliers. Supply chains cannot be rewired overnight. Building domestic cell gigafactories, upstream refining capacity, or alternative magnet and rare earth processing outside China requires sustained investment, permitting, workforce training, and secure feedstocks. Federal policies aimed at reshoring, including semiconductor subsidies under the CHIPS program and tax credits under the Inflation Reduction Act that tie EV incentives to domestic battery content, have mobilized capital. Yet firms also follow economics. Many established auto suppliers continue to source components where scale, vertical integration, and cost advantages are strongest. Trade and technology levers shape the strategic landscape. The U.S. maintains technological leadership in software, systems integration, and some advanced semiconductor design, but foundry capacity for leading-edge nodes is concentrated in Taiwan and South Korea, while extreme ultraviolet lithography machines come from a handful of suppliers in the Netherlands and Japan. This creates single points of failure in a high-tech auto future where chips and software are as critical as batteries. Meanwhile, China's control over processing of certain critical minerals and rare earth elements, documented by geoscience and trade agencies, gives it leverage in permanent magnets and other components used in electric drivetrains. Economic isolation would be costly, but not impossible. A decoupling scenario would force higher prices for consumers, slower rollout of lower-cost EVs, and disruptions in model availability as automakers reorganize supplier bases. It would also accelerate parallel development. U.S. and allied efforts to scale domestic cell makers, invest in recycling and alternative chemistries, and secure upstream supply through partnerships and investment abroad. Some companies are already diversifying procurement and building North American plants for battery cells and component casting. Others are expanding production in allied markets to avoid single market dependence. Ultimately, survival as an island depends on three practical pillars: supply chain resilience, industrial policy sustained over the long term, and international partnerships that substitute for markets and inputs lost to a China-centric world. The U.S. can preserve high-value segments like software, advanced manufacturing, and design while recruiting global partners to share upstream burdens. But success requires blunt trade-offs: higher short-term costs, targeted incentives tied to domestic sourcing, and a willingness to commit to multi-year industrial programs that match the scale of the challenge. The risk is real. The response will determine whether the American auto industry remains integrated into a pluralistic global market or becomes a smaller, more expensive alternative to a Sino-centric automotive ecosystem. The Tech Blitzkrieg. Chinese manufacturers built out battery cell and materials capacity to such an extent that a large share of global lithium refining, cathode and anode production, and cell assembly now occur inside China, creating choke points that foreign competitors could not ignore. The U.S. response combined incentives and restrictions. The CHIPS and Science Act authorized roughly $52 billion for domestic semiconductor manufacturing and R&D, while the Inflation Reduction Act committed roughly $369 billion toward clean energy and climate investments and created an EV consumer tax credit of up to $7,500 for qualifying vehicles. Those three policy levers, supply chain finance, consumer incentives, and export controls on advanced chips, shaped the front line of the technological contest. Automakers and suppliers reacted fast. Chinese firms leveraged integrated supply chains, and scale. BYD's reported new energy vehicle output exceeded 1 million units in multiple recent reporting cycles, making it the world's largest NEV seller by volume according to its own disclosures, and Tesla's global deliveries crossed the million-plus mark in the same era, underscoring the magnitude of the market shift. Semiconductor scarcity earlier on forced assembly line stoppages and production cuts at several major global manufacturers, a vulnerability that exposed the degree to which modern vehicles depend on advanced chips for battery management, ADAS, and infotainment. Pressure to secure chips and cells led U.S. OEMs and suppliers to announce multi-billion-dollar investments in electrification and advanced manufacturing. Ford and General Motors publicly outlined tens of billions in planned EV and autonomy spending, each move doubling as both a business pivot and a strategic countermove. Export controls on advanced semiconductor technologies, instituted by U.S. agencies, complicated China's access to the most capable logic and AI chips and to some high-end lithography equipment. At the same time, China funneled state-backed credit and land use incentives into battery factories and EV manufacturing clusters, accelerating scale economies for firms such as CATL and BYD and enabling aggressive pricing that squeezed margins at Western rivals. The result was a fast-moving cycle. Chinese suppliers scaled production and lowered costs. Western firms and governments shifted policy and capital to rebuild domestic capabilities. Supply chains fragmented and regionalized along technological security lines. On the software and systems front, Chinese tech firms pushed into vehicle electronics, mapping, and connected services, bringing smartphone-style integration to the car cockpit and tying in large user bases for data and services. U.S. efforts emphasize secure, domestic chip production, and stricter controls on semiconductor exports, while federal grants and tax credits aim to coax battery gigafactories and semiconductor fabs back onto American soil. The dynamic played out across boardrooms and bureaucracies. Procurement decisions at auto companies started to weigh not just cost and quality, but provenance and supply chain resilience. Market signals and regulatory fences reshaped supplier relationships, accelerating alliances with domestic chip foundries and prompting joint ventures to localize critical inputs. The human cost and industrial drama were visible in plant scheduling notices, supplier restructurings, and the race for talent in battery chemistry and power electronics. Skilled engineers moved between startups and legacy OEMs. National labs and universities prioritized battery research and semiconductor process technology. Meanwhile, consumer incentives altered demand shape. The EV tax credit rules shifted purchasing patterns by favoring vehicles meeting domestic content and final assembly criteria, influencing sourcing decisions all the way up the supplier ladder. Each policy, each investment, and each supply chain disruption became a plot beat in a larger narrative of competitive adaptation, where manufacturing scale met geopolitical strategy and where the automotive future was increasingly decided by control of chips, cells, and the software that ties them together. Speed is king. China builds cars like iPhones, new models every 18 months. The West takes 5 years. Chinese manufacturers have restructured product development to prioritize cadence and continuous improvement, aligning car rollouts with the tempo of consumer electronics. Analysts and company filings from leading Chinese OEMs and startups show release strategies that favor major model refreshes roughly every 18 months, paired with frequent over-the-air feature updates. Supply chain reports and industry associations in China confirm a dense domestic supplier base for batteries, power electronics, and semiconductors, which shortens lead times and enables rapid iteration across hardware and software simultaneously. The mechanics are plain. Automakers build on modular electric platforms that separate core chassis architecture from rapidly changeable exterior and interior modules. This lets engineers swap design elements and tech stacks without retooling entire production lines. Examples from investor presentations at BYD, NIO, and XPeng describe platform reuse and software-first development, while battery suppliers and Tier 1 firms advertise standardized interfaces that support frequent upgrades. Moreover, large domestic battery manufacturers and electronics contractors provide scale and component reliability, reducing procurement cycles that traditionally slowed Western programs. Western OEMs still follow a different rhythm. Long-standing processes, complex multinational supplier networks, and regulatory testing regimes generally produce full-generation vehicle development cycles that average several years between major redesigns. Volkswagen, General Motors, and other legacy groups have publicly outlined multi-year platform programs, investments intended to amortize tooling and engineering costs over multiple model years. At the same time, these companies are adopting electrified modular platforms and software stacks, but the transition often coexists with legacy combustion vehicle processes that constrain speed. Market dynamics and consumer expectations shaped the shift in China. Urban consumers accustomed to rapid smartphone refreshes demand comparable novelty in vehicle tech and user experience. Companies responded by collapsing traditional release gate timelines, running parallel engineering sprints, and leaning heavily on digital sales channels that accelerate feedback loops. This strategy is reinforced by regulatory and industry reports that highlight the scale of China's NEV ecosystem and the pervasiveness of OTA capability across new models, factors that together create a product development environment optimized for speed. There are trade-offs worth noting. Faster refresh cycles can drive higher R and D burn and complicate after-sales service and parts forecasting. Independent audits and warranty disclosures from various manufacturers highlight the operational pressure of accelerated launches. Nevertheless, industry intelligence shows Western automakers are adjusting. They are consolidating platforms, investing in in-house software teams, and streamlining supplier agreements to shorten cycle times. The result is a competitive landscape where speed is increasingly a differentiator, and where the smartphone-inspired cadence pioneered in China forces legacy players to rethink development, production, and customer engagement in practical, measurable ways. The battery trap. China controls 80% of the minerals. You can ban the car, but you can't ban the components. IEA assessments and USGS data together make clear that control of the lithium-ion battery supply chain is concentrated upstream and in processing, not only at the mine face. Analysts from the International Energy Agency have reported that a substantial majority of global refining and chemical processing capacity for battery materials sits inside China, and U.S. Geological Survey summaries show that while countries like Australia and the Democratic Republic of Congo supply large shares of raw lithium and cobalt, or respectively, much of the conversion from ore to battery-grade chemicals occurs elsewhere. Estimates from these official sources and industry analyses place China's share of key processing steps, graphite purification, precursor cathode active material production, and cathode/anode manufacturing, in the high tens of percent. In some subsegments, the nation's share exceeds 4/5 of global capacity. A deliberate chain of industrial choices explains that concentration. State-backed investment, preferential finance, and the creation of dense industrial clusters enabled companies to move beyond mere cell assembly into the dirty, chemical-heavy business of refining and precursor synthesis. At the same time, coordinated upstream deals secured access to ores and concentrates abroad, especially in countries that export raw cobalt and other critical minerals. Processing complexity, economies of scale, vertical integration, and a willingness to build the chemical plants required for cathode active materials created a durable competitive edge that is hard to unpick at the stroke of a policy pen. That structural advantage underpins the grim axiom: you can ban the car, but you can't ban the components. Trade restrictions on finished vehicles or foreign OEMs do not stop the flow of electrolytes, precursors, cathodes, or processed graphite across borders. Batteries in cars assembled in North America, Europe, or elsewhere frequently contain materials that were refined, processed, or even manufactured into cells in Chinese facilities or in plants dependent on Chinese precursor imports. Supply chains are layered. A chassis imported from one country might be married to battery cells whose active materials trace back through Chinese refineries to ores mined on another continent. Short-term import bans, therefore, create sourcing bottlenecks without resolving the underlying dependence. Policymakers have reacted with a mix of diversification, subsidy-driven onshoring, recycling, and strategic stockpiling, but none of these is a simple fix. Grants and tax incentives can underwrite new processing plants, and recycling technologies can reclaim lithium, cobalt, and nickel from spent cells, reducing import exposure. Yet building chemical refining capacity requires specialist operators, faces stringent environmental permitting, and needs large, continuous feedstock flows to be profitable. Governments have also leaned on trade diplomacy to secure alternative suppliers and push for industrial partnerships with allied countries. These moves are meaningful but gradual in impact. The strategic lesson is stark. Control of refined components is a form of leverage that outlasts car tariffs and market barriers. Nations contemplating bans or exclusion lists must pair those measures with credible industrial strategies. Long lead time investments, technology transfer agreements, recycling scale-ups, and stockpile management in line with national defense stockpile practices to regain resilience. Otherwise, the market reality remains. Finished cars are visible and ban-able, but the chemical guts that power them are diffuse, transnational, and anchored in processing networks that cannot be unwound overnight. The New World Order. China now holds the dominant position in electric vehicle assembly and battery manufacturing, a fact emphasized by reports from the International Energy Agency and China's own industry associations. Battery cell gigafactories and downstream battery pack assembly proliferated across coastal provinces, backed by state-backed financing and concentrated control of processing for critical minerals. Companies such as BYD, expanded rapidly beyond domestic borders, leveraging integrated supply chains that stretched from spodumene processing to cell production and vehicle assembly. Tesla's Shanghai factory became a pivotal export hub, demonstrating how international automakers adapted by localizing manufacture inside China. At the same time, government documents and press releases from the U.S. Department of Commerce and the White House signaled a strategic pivot. Incentives to onshore battery and semiconductor production, paired with export controls on advanced chips, reshaped the rules of engagement without declaring outright open conflict. Trade remedies and competition inquiries crystallized the geopolitical stakes. The European Commission opened formal anti-subsidy investigations into Chinese electric vehicles and U.S. policy instruments. Notably, the clean vehicle tax incentives tied to regional content rules and the semiconductor-focused industrial support programs forced global OEMs and suppliers to reconfigure sourcing strategies. Suppliers responded by establishing regional hubs, and automakers split investments between China-centric supply chains and Western onshore facilities. The result was a bifurcated market architecture, one integrated around Chinese manufacturing capacity and another organized under allied industrial policy umbrellas seeking secure access to chips, cathode precursors, and high-end power electronics. Corporate maneuvering became as important as state policy. Automotive groups that embraced joint ventures, equity partnerships, and battery offtake agreements with Chinese and allied suppliers secured volumes and pricing stability. Companies that lagged in securing semiconductor contracts or reliable battery supply chains faced production shortfalls and write-downs. Official filings and investor presentations reveal how capital allocation shifted. Rapid write-offs for legacy internal combustion platforms, simultaneous capital commitments to EV platforms and software stacks, and how these decisions accelerated market consolidation. Short bursts of factory idling and extended supply chain lead times told a clear story. The old automotive hierarchy fractured under the combined pressure of technology transition and geopolitical supply constraints. In-state dynamics emphasize control over four assets: battery chemistry and cell capacity, critical mineral processing, advanced semiconductors and power electronics, and vehicle software ecosystems. Public policy documents from multiple capitals show deliberate attempts to tether these assets to national security and industrial strategy, not merely market competition. Companies that prioritized vertical integration, diversified raw material sourcing, and alliances with trusted suppliers navigated the upheaval. Those that remained dependent on long-distance third-party suppliers or on legacy IC demand patterns found themselves marginalized. The new alignment of trade policy, corporate strategy, and technological leadership thus rewrote the competitive map of the auto industry, creating a multipolar industrial order anchored in supply chain sovereignty and platform control. The split, a polarized market. The U.S. stays old school and protected, while the global South and Europe become a Chinese playground. The United States enshrined protection into law and tariffs that shape market outcomes. Passenger cars enter the U.S. under a low statutory tariff of 2.5% off, while light trucks face a 25% off levy, and federal procurement rules plus by American and EV tax credit regimes condition market access on domestic content and final assembly in North America. The federal EV incentive framework offers up to $7,500 in consumer tax credits, but ties eligibility to specific battery mineral sourcing and component thresholds, effectively privileging suppliers with North American or allied supply chains. Trade enforcement agencies and customs documentation requirements further raise the barrier for imports that do not meet these standards, making straight export plays into the U.S. costly for fully China-based supply chains. China, meanwhile, built a horizontally integrated industrial base that feeds global vehicle exports. State-guided financing, targeted subsidies, and massive scale in battery manufacturing created a concentrated supplier landscape. The largest lithium-ion battery producers now represent about one-third of global cell shipments, according to industry trackers and company filings. That scale translated into aggressive pricing, vertical integration from cathode to pack, and rapid model cycles enabled by large domestic component suppliers. Official manufacturing statistics and industry associations document China's move from domestic dominance to export orientation, with national logistics firms, ports, and trade policies smoothing routes to Europe, Southeast Asia, Africa, and Latin America. Europe and much of the global South became hospitable markets as a result of that output and price advantage. European customs and registration data show a clear uptick in Chinese brand passenger vehicle entries across multiple member states, especially in the compact and mid-sized EV segments, where lower purchase prices, long manufacturer warranties, and extensive over-the-air update strategies have proven attractive. In emerging markets, concessional finance and leasing arrangements tied to Chinese manufacturers, supported in many cases by state-owned or policy banks, lowered total cost of ownership, and opened distribution channels where legacy OEMs had long been constrained by weaker dealer networks. The result was a cascade. Competitive pricing and local financing pushed market share gains, while European regulators initially negotiated safeguard reviews even as consumer adoption accelerated. That divergence hardened into a polarized market structure. The U.S. market, insulated by tariffs, procurement rules, and content-tied subsidies, preserved a stronger footprint for incumbent domestic OEMs and North American suppliers. But the cost of higher consumer prices and slower penetration of some low-cost EV models. Europe and the Global South, by contrast, saw Chinese OEMs capture volume through aggressive pricing and integrated battery supply, prompting European manufacturers to pursue partnerships, localized production, or technology licensing to remain competitive. Global supply chains bifurcated. One thread running through China-led assembly and battery ecosystems serving export markets, the other running through North American and allied supply chains benefiting from protectionist policy levers. The plotline that emerges from official data and industry reports reads like an industrial thriller. Early investments in cell capacity and raw material processing built an export engine. Policy countermeasures in Washington formalized a defensive posture, designing incentives that favored reshoring and allied sourcing. European pragmatism, balancing industrial policy, consumer demand, and antitrust concerns, led to a patchwork response. Some countries tightened scrutiny, others prioritized affordability and green adoption targets by welcoming competitive imports. The consequence is a durable split. Two distinct automotive worlds where regulation, industrial policy, and supply chain geometry determine which cars travel which roads and which firms set the market price. The verdict, the 100-year Western reign, is over. The car is now a gadget, and China owns the factory. According to the International Energy Agency and trade data from UN Comtrade and national associations, China now produces more than half of the world's electric passenger vehicles and concentrates a dominant share of battery cell manufacturing capacity. Major battery makers headquartered in China account for roughly a third of global cell output individually, while combined Chinese cell plants represent roughly three-quarters of announced global capacity in industry analyses by Bloomberg and EF and other market trackers. Those are not abstract statistics. They translate into real leverage over the parts that define modern cars: packs, modules, battery management systems, and the raw supply of cathode and anode materials. Scale turned into competitiveness. State-backed industrial policy, large-scale capital allocation, and procurement by domestic fleet buyers allowed Chinese manufacturers to amortize factories quickly and push down cost per kilowatt hour, a fact noted repeatedly in IEA and industry reports. Homegrown OEMs, such as BYD and supplier giants like CATL, moved from supplying domestic demand to servicing export markets, while foreign firms built local assembly and cell plants inside China. Tesla's Shanghai facility being a visible example of that reverse direction investment. China did not simply build factories. It built an ecosystem that includes mines, refining, chemical processing, and specialized automation, shrinking the role of distant suppliers and compressing lead times. The transformation of the automobile into a gadget is visible in every balance sheet. Hardware margins have thinned as battery packs and electric drivetrains commoditized, while software, connectivity, and services carry higher lifetime revenue potential per vehicle. Over-the-air updates, in-cabin apps, and data monetization are now core features, and Chinese companies have engineered tight vertical stacks combining hardware control units, app ecosystems, and consumer-facing subscriptions. Western carmakers increasingly license software or integrate modules sourced from Chinese suppliers. And industry surveys show software-defined vehicle features are a primary driver of new procurement decisions by fleet operators and retail buyers alike. Control of the factory is therefore both literal and strategic. Ownership of plants matters, but so does control of the supply chain nodes that feed them. Cell fabs, electrolyte and precursor plants, and the battery recycling infrastructure required to close material loops. Official trade and industry figures highlight a surge in Chinese passenger vehicle exports and growing market share in Europe and other regions, underscoring how production capacity built for domestic scale became an export machine. The result is a geopolitical industrial posture in which many Western automakers depend on Chinese-made cells, modules, or software stacks, even when final assembly occurs abroad. Practical consequences follow. Procurement teams in Europe and North America face longer-term exposure to Chinese suppliers for critical components. Governments and regulators increasingly cite that dependence in policy discussions. At the same time, Chinese firms are expanding R&D spending on vehicle electronics and advanced driver assistance systems, challenging the historical advantage Western brands held in software and systems integration. The verdict, based on publicly available production, export, and capacity data from agencies and industry trackers, is less an apocalyptic end than a recognition. Manufacturing gravity has shifted. The car's value proposition is now centered on electronics and services, and the factories that matter most, and much of the supply behind them, are firmly in Chinese hands. Over the last 2 decades, the plot has been unmistakable. China moved from follower to frontrunner while the U.S. struggled to adapt. Key points to take away. China has been the world's largest auto market since 2009. OIC. It now dominates electric vehicle sales with roughly 60% of global EV purchases in 2022, and Beijing's mix of industrial policy, incentives, and rapid factory expansion built a commanding position in batteries and electric powertrains. The U.S., by contrast, saw production fall from its peak and faced legacy labor and capital constraints. Yet policy shifts like the Inflation Reduction Act, including up to $7,500 in EV tax credits, and new federal investments signal an aggressive attempt to rebuild domestic capacity. If you've been tracking this story, you know it's not just about companies, but about supply chains, national strategy, and the cars we drive every day. For you as a consumer or an investor, that means choices about where technology comes from, how resilient the market will be, and which models will outlast the shakeout. If this ending left you wanting more, subscribe and hit the bell. We'll follow up with a deep dive into battery supply chains, raw material geopolitics, and the manufacturers racing to win the next decade. Check the description for primary sources and data we cited. Leave a comment with what angle you want next, and share this with someone who cares about where the auto empires are headed. The final chapter isn't written yet, and the next episode will show who's turning the page.